Good evening, Algebra students. We are still in Chapter 4, and remember, we're talking all about how two quantities relate to each other. And we can describe these quantities by graphing and having coordinates, ordered pairs, and tables. Well, today we're going to talk specifically about graphing a function rule, and a function is going to compare, two variables in this class at least, and we would like to be able to have a strategy for graphing when we have an equation. So first off, we have a little bit of vocabulary, and it is the set of all solutions xy of an equation forms the equation's graph. And then we can use a table, or using a table can help you graph an equation. So that's what we're going to do today. We're going to set up tables to help us organize our work and then plot our coordinates on the coordinate plane. So in my first example, it says, what is the graph of the function rule y is equal to negative 2x plus 1? Well, what I'm going to do is I'm going to make a table. That's my first step. So I'm going to say x, and then I'm going to put the function rule in the middle so I can substitute into it. So I have negative 2 times x plus 1, and then I'm going to put my y over here because this says y equals all this junk. Well, if I could figure out what all this junk equals, then that must be what y is. So I have x, the function, and then y. Now, when it comes to your x values, you can come up with whatever numbers you want. My advice is to keep your numbers simple. Just substitute in easy numbers. So I'm going to say 0, 1, 2, and 3. And now I'm going to substitute 0 in for x, 1 in for x, 2 in for x, and 3 in for x, all on their own line. All right, then I'm going to simplify what's in the middle column. So negative 2 times 0 plus 1 is equal to 1. So that means that 1 goes in my y value spot. Let's do it again. Negative 2 times 1 is negative 2, and then negative 2 plus 1 is going to be negative 1. Negative 2 times positive 2 is negative 4. Negative 4 plus 1 is negative 3. Finally, I have negative 2 times 3, which is negative 6, plus 1, which is negative 5. So at this point, I have my ordered pairs. I have my x's and my y's, and I'm going to rewrite them one more time, but I'm going to go ahead and highlight my axes just so you can see them a little bit easier. And my coordinates are 0, 1, 1, negative 1, 2, negative 3, and 3, negative 5. So I'm just going to write those out to the side just so we can see them together a little bit easier. And then I'm going to start graphing. So I'm going left and right none and up 1. Then I'm going over 1, down 1. Then it's 2, negative 3, so over 2, down 3. And then 3, negative 5, so over 3, down 5. 1, 2, 3, 4, 5. Yes, that's correct. And then I'm just going to connect those dots as best as I can. I know I kind of missed them a little bit, but whatever. And here is my graph of that function rule. You don't have to do, 20 different points. Once you get a couple, then you should have a pretty good idea about what's going on in that problem. So we're doing that same exact thing with these two guys down here. So we're going to set up our table first. So I have x, then my function rule is 1/2 x minus 1, and then y. Now, remember what I said up here at top. Choose numbers that are going to be easy for you to solve for. Because I have this 1/2 in the function rule, I'm going to only choose even numbers because I don't want to work with decimals. If you do, that's fine, but I'm looking at the problem ahead of time and thinking to myself, how can I strategize to make this work easiest on me as possible? So I'm going to say my coordinates are -2, 0, 2, and 4. I'm choosing even numbers so that when I multiply it by 1/2, I get a whole number for my answer. Now I'm taking these numbers and substituting them in. And then I'm going to simplify this middle column to get my y values. So 1/2 times -2 is equal to -1. -1 minus 1 is -2. 1/2 times 0 is 0. 0 minus 1 is -1. 1/2 times 2 is 1. 1 minus 1 is 0. And then 1/2 of 4 is 2. 2 minus 1 gets me +1. So now I have my table completely filled out. I'm going to write the coordinates out to the side again just so you can see them. So I've got -2, -2, 0, -1, 2, 0, and 4, 1. Now I'm going to put that on my coordinate plane, and I need to highlight the axes again for us so we can see them. And now we are ready to plot our coordinates. So -2, -2, that's back 2, down 2. And then 0, -1 is left and right none, down 1. 2, 0 is over 2, up none. And then 4, 1 is to the right 4 and up 1. And then I'm ready to connect the dots. Let's do that again with this problem. So y is equal to -1/2 x plus 2. So I have my x and then my function rule and then y. Once again, because I have a half in there, I'm going to only do even numbers, and I'm actually just going to stick with these same even numbers for my x's for this one as well, because that's just going to be quick and easy. It's okay to use simple numbers to solve the problem. That's more than fine. So I'm going to have -1/2 times -2 plus 2, -1/2 times 0 plus 2, -1/2 times 2 plus 2, -1/2 times 4 plus 2. All I did was I rewrote this expression up here over and over and over, but instead of x, I put in the value that I wanted x to be. Now I'm going to simplify that, and I am going to be getting 3, 2, 1, and 0. Yeah, because -1/2 times 4 is -2, and -2 plus 2 is 0. Yes. All right, so now I have my coordinates. They are -2, 3, 0, 2. Let me move that up a little. 2, 1, and 4, 0. And let's plot those. So we have -2, 3, back 2, up 3. And then 0, 2, left and right none, up 2. And then we have 2, 1, and then finally 4, 0. So we go to the right 4 and then up none. And that's my line right there. So notice it's all about setting up the table, substituting in your values, and then you get your coordinates. Now there are different types of graphs that you can have, and these are called continuous graphs or discrete graphs. A continuous graph is a graph that is not broken or unbroken. It is continuous. It never stops. It continues. While a discrete graph is a graph of individual little points that are not connected to each other. So we're going to be seeing that in action here in just a moment, but we have a little bit more vocab. So it says, when you graph a real-world function rule, choose appropriate intervals for the units of the axes. Every interval on an axis should represent the same change in value. So it's important if you have numbers like 5,000 and 10,000, hopefully you're not counting by ones because that would be a gigantic graph. So you might have to make your units 100 or something like that. And then we just want to keep it consistent. Our numbers shouldn't be jumping around. And then we also only want to show the parts of the graph that are necessary. So if there are parts of the graph that aren't important to the problem, then we don't necessarily need to show that because it could be confusing for an audience. And if it's not important information, then we shouldn't be showing it. So here we have a word problem, and we're going to see this continuous versus discrete graph in action. So it says, a local cheesemaker is making cheddar cheese to sell at a farmer's market. The amount of milk used to make the cheese and price at which he sells the cheese are shown. Write a function for each situation, graph each function. Is the graph continuous or discrete? So my first scenario is 1 gallon of milk makes 16 ounces of cheddar cheese. This costs is supposed to be over here. There we go. That was just like a spacing issue in the computer, I guess. So 1 gallon of milk makes 16 ounces of cheddar cheese. So here are our two variables. How much milk is used and how much cheese gets made. Or how many gallons of milk gets used and how much weight of cheese gets made. So I'm going to say the amount of cheese that gets made is equal to 16 per the amount of milk that we use. So we get 16 ounces of milk per 1 gallon of, 16 ounces of cheese per 1 gallon of milk. So cheese is equal to 16 times milk. Now I have my function rule and I'm going to start setting up my table. Your input is the milk because you need the milk first. So that's another way you can kind of think of dependent and independent. The cheese is not making the milk is making the cheese. So you got to do milk first. So we're going to say M, and then 16M in the middle, and then C. And we can just choose easy numbers once again. So what if we use 1, 2, 3, or 4 gallons of milk? Substitute that into the middle column. So I have 16 times 1, 16 times 2, 16 times 3, and 16 times 4. And then I'm going to multiply that and get how much cheese ends up getting made. So that's going to be 16, 32, 48, and 64. Notice all I'm doing, I'm taking 16 times 4 equals 64. 16 times 3 equals 48, and so on and so forth. Now it's time to graph. So I'm going to label my axes and figure out my units. The bottom is going to be milk in gallons, and the side is going to be cheese in ounces. Now, because this graph isn't super big, I'm going to actually label these by eighths. So I'm going to have 8, 16, 24, 32, 40, 48, 56, and 64. So I decided to go by eighths so that I could be sure that I got all my numbers in there. And for the bottom, I'm just going to go by ones. So 1, 2, 3, and 4. Now it's time to plot. If I use 1 gallon of milk, I get 16 ounces of cheese. So I go over 1 up to 16. If I use 2 gallons of milk, I get 32 ounces of cheese. So I'm going to go over 2 up to 32. If I have 3 gallons of milk, then I get 48. So I'm graphing that, and then 4 goes with the 64. Now, how do you know if you should connect the lines or not? Or connect the dots or not. We are going to connect the dots here because you can make the cheese with any amount of milk that you want. You could have used a half a gallon or 3 3/4 gallons, and that would end up yielding a proportionate amount of cheese. So I am going to connect these because any amount of milk would produce any amount of cheese based off of this function. Okay, let's look at the second one. It says each wheel of cheddar cheese costs $9. So now my two variables are cost and how much cheese. Or money, I guess you could also say. So the amount of money that we're making, so I'm going to say money under there as well, and I'm going to let it be M. So the amount of money that we make is going to be $9 per cheese wheel. So I'm going to say 9C. Now, the cheese brings in the money does not bring in the cheese. So we need to do C first, and then we have 9C, and then M. So what happens if he sells 0 cheeses, or 1, 2, or 3? I substitute in that number into my middle column, and then I start calculating for how much money he's going to earn. So he would earn $0 if he doesn't sell any cheese. That makes sense. He would only earn $9 if he sells 1 wheel of cheese. He would earn 18 if he sells 2, and he would earn 27 if he were to sell 3. So now I'm going to label my axes. I'm going to go by 3s. So 4 up and down, 3, 6, 9, 12. There we go. And then I'm just going to go by 1s on the x-axis. Now here is how much cheese is sold. So I'm going to say sold cheese. And then I'm going to say cost or profit, whatever. Okay, so if he sells 0, then he earns 0. So that's at 0.00. If he sells 1, he earns 9. So that's over 1, up 9. If he sells 2, then he earns 18. So that's over 2, up 18. And then if he sells 3, he gets 27. Now, we are not going to connect the dots on this graph because he is not selling 1/3 of a wheel of cheese. He's not selling half of a wheel of cheese. He's only selling full wheels of cheese. So that means that the graph will not continue for all values. It needs to be those specific number pairs. So that's kind of the difference between continuous and discrete in a real world application. All right. We do have one more page of these notes, but it's very, very similar to the word problem that we just did, and I think we'll be able to go a little bit quicker on this one because we're actually given the formulas. So it says, or equations. So it says graph each function rule. Is the graph continuous or discrete? And for A, it says the amount of water, W, in a wading pool in gallons depends on the amount of time, T, in minutes. The wading pool has been filling. So, time T in minutes, the wading pool has been filling. As related by the function rule, W equals 3T. They're telling us the function rule already. So I'm just going to do that in column A, just so we don't forget about it. We're talking about water filling up a pool over a certain amount of time. So we have time influencing how much water is in that pool. And what happens if 0 minutes pass, 1 minute, 2 minutes, or 3 minutes pass? That's what we're asking ourselves right now. Well, I can use this equation that they gave me down here, just kind of over to the side. And because it's such a simple equation, I think we can do it in our head. So To find W, where t equals 0, it would be 3 times 0, or 0. If no time passes, then no water is in the pool. Now, if 1 minute passes, then that means 3 gallons are now in the pool. If 2 minutes pass, then that means 6 gallons are in the pool. And if 3 minutes pass, then that means 9 gallons are in the pool. And the way I'm doing that is I'm taking this t value and I'm substituting it in here, and I'm taking it, multiplying it by 3 to get W. So now I have my coordinates. I have a couple points. I'm going to start plotting these. So I have time, and I have water in gallons. And I think that I can just go up by ones on both. So that's what I'm going to do. So let's start my first one. I have 0.00, so that's going to go right here. Then I have 0.13, so I'm going to go over 1, up 3. Then I have 0.26, I'm going to go over 2, up 6. And then I have 0.39, which means I go over 3 and up 9. Now, as the water is flowing into the swimming pool, is the water going to randomly stop every minute, or does it just continue flowing through time? It continues flowing, so that means that this is going to be continuous, and I need to connect the dots, and I'm just going to circle continuous, meaning that's what it is. It is continuous. We have one last problem, and then we're done. It says the cost C for basketball tickets in dollars depends on the number N of tickets bought, as related by the function rule C equals 16N. Once again, we are given the equation, so we can just start substituting these in. Basically, how much is the bill going to be? How much is it going to cost based off of how many tickets we buy to this basketball game? So if we buy 0 tickets, 1 ticket, 2, or 3, that's plenty for us to figure this out. My equation is C is equal to 16N. So the cost is going to be 16 times N. Well, if N equals 0, if I buy no tickets, then it's going to cost me nothing. If I buy 1 ticket, then it's going to cost me $16. If I buy 2 tickets, it will cost me $32. And if I buy 3 tickets, it's going to cost me $48. So now I have my coordinates, 0, 0, 1, 16, 2, 32, 3, 48. I am ready to start graphing. Along the bottom is my number of tickets. And along the side is going to be the cost. Now these numbers start getting pretty high, and clearly I don't have 48 boxes going up and down. So I am going to label these by 4s, but I'm still going to skip every other, I think. So I've got 8, 16, 24, 32, 40, and 48. Okay. And then I have 1, 2, 3, 4 down here. If we buy 0 tickets, it costs $0. If we buy 1 ticket, it costs $16. If we buy 2 tickets, it costs $32. There we go. And then if I buy 3 tickets, it's going to cost $48, and then I'm running out of space on the graph. So with this, should it be discrete or continuous? Well, ask yourself, can I buy 1.5 tickets? No, I cannot. So this is going to be discrete because I cannot buy a smaller interval between these whole numbers. And that's all we have for today. Thanks for sticking with it. I know it was a long video, but I hope you have a good night, and I'll see you tomorrow. Bye.